Good afternoon and warm greetings to all. I am Binay Singh from Integration Support Team AVDM NHA. Today, we are arranging a session on FHIR implementation for benefit of all the integrating partners. Since one of the mandate for being a part of AVDM ecosystem is being FHIR compliant, and this session will help you to clarify all your concerns regarding FHIR. Note to all, this session will be recorded and available on Sandbox website. Please keep yourself on mute. We will be having question answer session in last 30 minutes. You may raise hand features uh, in team for speaking. Now I introduce to all with Ms. Manisha Mantri, project head lead, co-investigator in RCS, joint director CDEC Pune. Ma'am, you may please take over the session.
Thank you, Vinay. Am I audible?
Yes, ma'am, you are audible.
Thank you. And good afternoon, everyone. And thank you for this opportunity where we can help all the implementers understand FHIR and the FHIR profiles for Ayushman Bharat Digital Mission. I hope my screen is visible, and I'll be taking all the participants today to go through on details on FHIR, what FHIR resources are, and followed by my presentation. My colleague Saili Pufarkar is also there on the call, who will help you to go through on how do you do the basic creation, validation of ABDM compliant objects in a development environment. Okay. Yeah. So today's agenda is we'll go through on little bit background how FHIR has been evolved, and then about FHIR, the different building blocks of FHIR resources, data types, bundles, and how the FHIR data communication happens. What are the different reference implementations available, and what does this profile means? What is this implementation guide, and a small walkthrough on the existing FHIR implementation guide for ABDM. And then how do we do the FHIR HR type development, and then how new HR types can be evolved in future based on the requirements from implementers, from NHA, from government. Okay. And then ultimately a small hands-on where we'll help you show how do you validate the FHIR compliant data object, the data structures. So why is these standards are important, and how the overall this ecosystem of data communication was evolved. So if you remember the previous scenario of data exchange, if you have looked at the older versions of standard specification like HL7V2, or even the older versions of the DICOM standard, which is the medical imaging standard, the focus was only data communication within the hospital, where there are multiple systems which are interconnected and trying to share data within the single hospital. And that's why the specifications there were evolved more looking at this very small scenario, and a lot of work on communication part is more focused on the socket based exchange, and then there is a message sharing, there is a acknowledgement, and then there is a data coming in, the payload coming in, and this way the whole exchange protocols were defined in healthcare as well. But if we kind of look in today's scenario, the complete, there is a complete change and shift in the requirements of data exchange. So we want data to be shareable across different divisions, different hospitals, different departments, and also more and more variables and the different portable devices and the applications are coming in, where data is collected at very different places, and we want them all to be collected and shareable between different systems. So this is the new need for modern way of health data exchange. So yes, data is not limited to hospital, and the data is more and more getting into the patient-centered approach. Even in ABDM, it is very clearly stated that patient is the owner of health records, and the whole the care paradigm in ABDM is also patient-centered. So looking at patient as the first user, what kind of data the patient would be requiring, all the HI types of ABDM have also been designed in the same way. So you imagine multiple systems like hospitals, labs, pharmacies, and every places data is coming in. Patient is going to all these places and data is shareable. So the problem is, the requirement is we want all the data shareable across all the system in the real time. And that's where interoperability comes in picture. And that's very, very important. And there are statistics where it says more the data is available, more facts per decisions are taken over the year. And that's why we want interoperability, and there comes standards in place. And coming on to evolution of FHIR, so as I said earlier, the requirements were completely different. The requirements were within the hospital data sharing. But since with this change over the way we are looking at data, the way the systems are designed, the way internet has been in the center for sharing of data, and then how do we define a healthcare standard which can take care of all of these requirements of easy to develop standard, easy to implement standard. So when I say easy to develop, the development of standard itself has to be easy. Then implementing such a standard should be easy, and it should be semantically robust in the sense that it should support all the different set of other connected standards like SNOMED, LOINC. You have coding systems, you have other imaging standards. So taking care of all of these data, because we want one in all solution, and not like share. If you want to share images, you do something else. You want to share this, you do something else. Not like that. All in one solution which is able to take care and able to get data from the multiple coding systems, multiple standard. That was the another requirement. And of course, implementer friendly. Why? Because more and more very specialized format designed, it takes more and more time for implementers to support. So easiest format to understand, any common tools that can be used to implement such a standard, use of web technologies, existing ones which are widely used and acceptable. So these were the few of the requirements while FHIR standard was looked into for designing, and should be able to integrate with all different modern web-based communication technologies. So these few requirements were there, and usage scenario was to be able to share data over internet, to be able to share data over mobile, small devices, able to do gross to the specific analytics on top of data, able to attest that data, able to support multiple coding system. So all of these were required, and that's where HL7 has come up with a new standard, which is FHIR. Full form is Fast Healthcare Interoperability Resource. So, giving a little brief on FHIR standard, what it is, it is basically a health data exchange standard developed and nurtured by HL7 International. It's being called as an internet-based standard because it uses all the internet-based approaches for connecting discrete systems and elements. It aims to build a base data set of something called resources. So I'll brief on the resources later. It creates a base data set of different entities that you use for communication and exchanging information. And these entities are actually called as resources. So there are around 150 standard defined resources. These resources have come up with a lot of effort, a lot of brainstorming, feedback from community, looking at the earlier experiences of standard development. So there are ready to use entities already there in FHIR, which you can use within your healthcare systems. And it supports three major data formats for data sharing: XML, JSON, and RDF format. And it also, the way the FHIR resources are developed, the specification itself supports the CRUD operations, like create, read, update, and delete on the different resources. And these resources are extensible by design. So what does that mean? I'll speak about in my later slides, in coming slides. And it has the terminology binding also in place for the popular code sets like SNOMED, LOINC, ICD, and other standard coding systems, whichever are used for coding of the data element. So why coding is important? We want standardized data representation as well in the health record. So it has these at all different places. It has the relevant data elements added to support these coding systems. And then what if you kind of look at these FHIR resources, they are basically divided into four different sub kind of groups. If you look at those are administrative resources, and then clinical resources, and research resources, and then the other resources. So these are the scoping in which FHIR and its resources can be used further. So why FHIR? Again, just trying to map it with the earlier goals that we discussed. It is implementation focused standard. Why? Because the implementation libraries are widely available. It has examples also available for reference implementation. It supports human readable serialization format as well. So the way FHIR standard is designed, you can have, so at each resource level, you can have human readable text also kept, so that it is readable in the small applications. Before processing, you can provide a summary before opening or processing any of the resources. And the specification is free for use with no restriction. It uses web standard including XML, JSON, HTTP, OAuth, and so on. And it has multiple ways, the way you can exchange data. So one is RESTful messaging, document-based sharing, and as well as the different types of services you can build on top of FHIR standard. And it is extensible by design, and it allows customization. So example of customization itself is, there is a noise coming in, if it can be stopped. Thank you. So one example of extensibility is FHIR Implementation Guide for ABDM itself is a customization of FHIR profiles for usage in the ABDM scenario in India. And it has the terminology bindings as well. So few key of the requirements. Now let's talk about how FHIR can be visualized in terms of its usage. So these are the three diagrams. I have tried to use it in a different way, the way it is represented in different slide in HL7 HL7 presentations, but for simplicity, I would say you can use FHIR for all the three mechanisms. One is you can do FHIR-based FHIR object-based data sharing. So considering you have the application A1 and application A2, and both of them talk in a common API, then you use FHIR as a standard structure for data sharing between A1 and A2. That's one of the scenario in which you can use FHIR. Now on top of it, you can use FHIR for exchange as well. So not instead of having a common API, you use the FHIR itself, FHIR specification itself as an API for communication between application A1 and A2. So what happens is application gets the exchange is also FHIR based, and the data structure also FHIR based. Now the third mechanism is the storage also can be FHIR based. So you store your baseline storage also FHIR compliant. The data exchange also happens through FHIR API, and the storage also happens through FHIR API. Now coming on to ABDM, in ABDM we have adopted the first approach, the FHIR object sharing mechanism, where ABDM has its own APIs. We have the APIs on how to create health IDs. We have our own APIs on how to get consent, how to share data, how to verify the health ID. And while sharing data, one of the payload on data is a FHIR object. And that's where ABDM uses FHIR. So the first scenario here, so first scenario here, so this is the first scenario in which FHIR has been used by ABDM. So what are FHIR resources? Let's talk about FHIR resources now. Actually, if you have come from the object-oriented programming, you know that you create certain entities which are logical and meaningful entities. For example, you have multiple data types, like you have integer, you have string data type, and you want to create a simple employee example. You want to create one logical entity which stores information about an employee. So you create a data structure called employee in the world of C, C++, or any other world. Or if you're talking in terms of Java or .NET world, you create a class called employee. And then in that class, you use the various data types with a naming convention that, it's a first name, middle name, last name, employee ID, and so on. So these are the entities that you create. So in healthcare, if you see, FHIR resources are those entities created by FHIR standards. These are the ready-to-use entity. You need not create any of the new entities or design them from the scratch. So the simple explanation of a FHIR resource, it's a logical entity which represent a particular structure which is meaningful for sharing and unit in its own entirety. So there's no one big resource, something which has everything into it. It's being divided, modularized, and made logical. The example of resources are simple: patient, practitioner resource, observation. So medical observation, if you want to record any of the observation, you have one resource. Organization is also one resource. So resources actually represent unit of exchange of the data that can be justifiable in interoperability. So standard definition for resource. And a resource has a known identity. Every resource is identified by a unique URL, which it can be addressed to. And then it has multiple information. The resource carries few metadata information, which is used for searching, cataloging. For example, an identifier. A resource has always every resource has an identifier. Every resource has the language set, which tells that in which language the data is coming in. So FHIR supports multiple languages as well. So whatever is the content of the data content can also be information about that data can be also captured in the metadata part of the resource. And then it has the structured specification. It has defined value sets for any enumerations also. So for example, if I say patient as a resource, and then I say patient has an identifier, and then there is something called identifier type, which is also a fixed value set. So whether this is a national identifier, it's a PAN number, or it's a medical record number, that can also be captured. So such value sets and enumerators can also be mapped to a resource. And it has a display element which can be used for directly printing or displaying on a HT on a simple web browser. It can be rendered on a simple web browser through. It has an HTML tag which can be used to put data which is readable, human readable, and for rendering purposes also. And it has links to other resources. So the way we have references in object-oriented programming, we have the contentments of the class. So one class can have another class as a containment, like you create an object of that class within that class and refer it. The same way, you can have links to the other resources as well. So what in all, we say that resource is a known entity which has an identifier. It has a defined meaning. It has a set of structured data element, and it has an identifiable version to it. So let's see. This is how the resource looks like. These are the key parts of resource. If you can see it, and I hope you are able to see it. So this part, if you can see, this is a meta structure of a resource where it says what is the version ID, what was the last date when the resource was updated, and which profile the resource adheres to. Now profile, if you again try to map it with the object-oriented world, this is the class. Profile can be kind of considered as a class, and the resource is an instance of a class. So this is an instance of a profile called patient. This is a patient resource. Now, if you see here the text part where it says, it has some text information in the div tag coming in with the patient name, ABC, age, as, and gender. So this is a human readable information which can be rendered. It can be generated or added on the fly based on whatever information is there within this resource. So if you see here, you can see the name as one structure coming in, the telecom as a contact number, a gender coming in, the birth date coming in here. So these are the information on the resource, and this is the identifier element for a patient resource. So this basically is a patient resource. And yes. So let's kind of try to browse how this resource looks like. Anybody said anything? So let's go and see the base specification of FHIR, which is provided by HL7 International. Okay. So Abdm uses FHIR R4 version of FHIR. FHIR also has multiple versions, R4 being the stable and normative version being adopted for Abdm. So if you can see here, I just click on the resources section, and you can see there are so many resources already defined. Okay. So let's go and see the patient resource, which is simple and easier to understand, or maybe we can take one condition resource, which is used for clinical purposes. So condition here, if you see in the resource structure itself, it explains what is the scope of usage of this resource. So for example, if you want to provide any conditions about patient, whether it is an observation or a clinical finding or a diagnosis, you can see here it talks about what all things you can provide information about a patient within a condition resource. Okay. And this is how the condition resource looks like. I will not speak right now about all of these information coming in, but I would like to put your focus more on this, the way the condition resource is structured. You can see here it has an identifier, it has a clinical status, which is again a codable concept. It's again one kind of a data type. and what is the severity of this condition, whether it's a critical or a normal condition, and then what is exactly the condition. So that also comes in decodable concept. So this is one kind of a data type in HL7. What was the body site where the condition is about which you are providing the condition? What is the subject? So you can see here it's a reference, and it is a reference. The subject reference is coming to the patient resource. So in clinical world, patient we refer as a subject. So the subject reference is again going to the patient resource, and the encounter reference is going to the encounter resource. So encounter is also one kind of a resource. So this is how the structures of the resources are defined in the FHIR. Not getting into more complexity of it, and let's go ahead on our presentation, and slowly we will try to make it easier for everyone to understand. Now, from resource, I'm just a little bit deviating here, and we are going to talk about something called bundle. So bundle is one special type of resource in FHIR, where when you want to share data, FHIR says that whenever you're sharing data over network, you have to share it within a bundle. So it's just kind of a packet on top of a resource. So any data you share it inside a bundle resource. So how? So you can share, for example, this is an example where I'll say there is a lab report in FHIR which can be represented as a set of related resources. So patient, requesting physician, observations, multiple observations on a lab report, and a report in a PDF format, and the associated order for that laboratory report. So all of them can be shared as an individual resources. However, in FHIR world, you bundle them all together. So any resource that you share, you need to put a bundle on top of it. So multiple resources also can be bundled in a bundle resource for a purpose of any logical transaction. So you must have seen in ABDM also data sharing happens through the bundle resource. So whenever you prepare an object for sharing, it's a bundle, and inside a bundle you have one of the HI type that is coming in ABDM. We will talk about those HI types also later. So these are the data types which are there in FHIR already used. So you can see here, one second, yeah. You can see here the data types like string are also there, integers are also there, URI are also there, and then there are certain special types of data type like codable concept, which keeps information of coded data. There is this coding which is used within the codable concept. There are something called attachment, ranges, period. So name a type of data type, it is there. Address is also created as one type of data type. Why? Because it is used at multiple places in healthcare. So address of a patient, address of a clinical facility, address where the laboratory tests has been carried out, address where the patient location is, and so on. So address is also a special type of data type which is reused in multiple resources in FHIR. And yes, so we will now talk about what are the different ways FHIR supports data sharing. Okay. So FHIR supports data sharing in 4 formats. One is the REST API format. So remember we talked about 3 ways you can use FHIR. So in those 3 ways, one of the way I discussed was using the FHIR-based APIs. So REST APIs, REST-based FHIR data exchange. Then there is second format, which is the document-based exchange. This is supported to kind of take care of the older HL7 CDA document-based exchange mechanisms within FHIR. And the third one is messaging, which supports the older HL7 V2 versions of data sharing mechanisms. Say, for example, get record and set record or add record. So these kind of this kind of APIs or this kind of messaging paradigm can be supported using FHIR. And then fourth is the services based approach. So the REST-based approach, the first one, uses HTTP GET POST kind of methods where there are predefined operations: create, read, update. So this all happens on a resource. So create resource, read resource, update resource, and of course on with a bundled resource on top of it. Then there is the second second approach is a document-based approach, which is more or less similar to HL7 CDA, clinical document architecture, where a collection of resources is bound together, where a root resource is a composition, which act just like as an header, and then sent as a bundle. So this composition is added into a bundle resource as one context, and then can be signed, authenticated, and shared. So our ABDM uses document-based paradigm for FHIR actually. So all our HI types, whatever are defined on a composition resource. So why? Because the use case of ABDM is very simple. It's about enabling continuity of care for patient. So whatever information that a patient requires while going from one hospital to other hospital for a care delivery has to be available to the other hospital as well. And that's where the different, I'm again getting some noise. Yes, thank you. And that's where the different use cases and the identified HI types have come in place. And then there is a third approach, which is messages based approach, which is there to support traditional V2 and V3 messaging, where you call like event driven driven data sharing, like send one entity says that send lab order, and then other entity says that get lab order, and it can be asynchronous, synchronous, indirect, and in a different mechanism ways. And then there is this fourth approach, which is you can decide the way you want to define services. However, the services have to be SOA based services only. You can create as complex ways of data sharing as possible and as simple workflows as possible. So we will focus now on the second approach, which is document based sharing, where composition is a root resource and has a bundle on top of it. Okay. So these are the different available reference implementations of FHIR. For Java, you have a very good open source implementation, FHIR implementation there, where it has the object models, parsers, client server frameworks, validator, and different utilities which you can use. And there are some other reference implementations are also available in C#, Pascal, XML, JavaScript, and Swift as well. And there are a few more, so list is available here on the link provided. Now coming on to the profiling, why do we need profiling, and what is this ABDM, FHIR profiles for ABDM, and the implementation guide? So now we will again try to see the FHIR resources. The FHIR specification, the way the FHIR specification is designed at the first place by HL7 International is it takes care of majority of the common use cases. For example, whatever data elements which are there listed in any resource are most of the time optional. And then there is a flexibility to extend or adopt it according to your local needs. So for example, if you look at the patient resource as well, most of the data elements are optional there. The name is also optional. So you can decide whether you want always name to be mandatory in your implementation, and you can say that in that name element also we need first name as a mandatory or family name or surname as a mandatory. So you can do those changes of I would say either restricting or using the specifications the way you want, which is suitable within your own implementation use cases. And that's where the beauty of FHIR comes in. And the conformance of the content of data and the operation is always needed. So you can't just say that, I'm making patient as a patient name as mandatory in my patient resource. How do others know whether the patient name is mandatory? So that's where you need to have your own implementation guide, where you specifically list that, these are the data elements which are mandatory for me for sharing data from one application to other application in any of these scenario. And then those mandations you can keep on profiles, you can keep it on operations, you can keep it on exchange. However, in ABDM we are referring to FHIR as a standard data structure for sharing of data. So we are focusing on resources rather than operations, because we have our own different APIs for sharing of data. And then and that's where whenever you do all of these customizations to resources, giving whether making the particular resource as a required or optional, or adding one more resource based on the requirement, or binding a particular terminology also. For example, in India, you want to support SNOMED City always for recording of procedures or recording of any clinical conditions or clinical findings for that matter, while data entry. So you can say that in condition resource, while coding, the binding will always come as SNOMED. So these kind of requirements you can put on your own resources. So all of these, when you do all of these operations, doing this all operation, the process of it is called as profiling. So FHIR profiling is the way to build consensus on content, operation, search parameters supported, and we are focusing more on the content. So you can decide which features you want to keep if you are looking at the operation side also. So about profiles and extension, so you can modify resource for constraining existing elements and fixing the value sets for the coded element. You can add new data elements or data type to the existing resources. They are called as extensions actually. So if you just constrain element, it's a profiling, and you add one more data element, adding anything to the existing resource is basically extending that resource, and that's why they're called extensions. So all of such definitions are called profiles basically. They describe a set of rules about how a resource to be used to meet general use case. This is a definition of profile, so we'll not talk about it. Let's go look at practically what it is and how the profiles look like. And when you build all of these profiles, when you develop, when you do all this constraining through the profiling process, you require a formal publishing of these definitions, because they are different than the existing international specification. And this publishing is basically called as implementation guide for FHIR. So what we have done in ABDM scenario, we profiled the existing FHIR resources of R4 version for meeting ABDM requirements, and those definitions are published with the explanation on the on the implementation guide for Ayushman Bharat Digital Mission. And now I'll show you how those looks like after one single slide, maybe. Yes. So let's first look at these profiles, how they look like, and then we'll go further. So this is the FHIR implementation guide for ABDM. So here, if you see here the profiles, if you click and check for the profiles here, you will see a list of profiles, and you will say, oh, it is only some 32 or 33 list of profiles, but FHIR has 150. So whatever changes are done in the FHIR resources, those will only be reflected on this implementation guide, where it is expected that other resources can be used on as-is basis from the existing international implementation. Now, I show the one way the profiling is done. Let's go again on patient resource. Okay. So this is the patient resource. And if you kind of see now here on the original specification document, you will find a resource called patient. Okay, it's a normative. Normative means it's being now the resource is a stable resource, and it has gone through multiple rounds of validations and corrections, and it can be used in the production systems as is. So this is a patient resource. So if you see here, the cardinalities part specifically, the third column on the structure, you can see all have the cardinality 0 or more, 0 or 1, right? So everything is optional in patient resource. Even the patient identifier is also kept optional. Why? Because it provides flexibility to implementers to use these profiles the way you want. Now, what we did is we picked this patient profile and did a profiling on this patient based on the requirement in ABDM. And we say that it is a differential view. So if you see the full view, this is the complete patient profile, but on this whole profile, which is visible in the differential view. And you can see that it says the cardinality is 1, which says that the identifier is mandatory while sharing any patient-related information through patient resource in ABDM. The identifier type is also mandatory. If you're sharing any identifier, a type has also to be mandatory, and so on. So you can see here the changes, few of the elements have been made mandatory. Now there comes this S flag also, right? So we will see what is the significance of these flags as well. That's there in the slide. Let me go through the presentation again now. So these are the FHIR profiles for ABDM. You know that these few clinical artifacts were considered. We use document exchange paradigm of FHIR, and we use FHIR as a structured data standard for data sharing and not using FHIR APIs directly. However, any implementers, the individual HMIS developers can use the whole FHIR standard for even for the data exchange within their own system. And so that what happens is your own application is complete FHIR compliant, while you will be able to share FHIR compliant data to ABDM as well. And these are the 7 HR types which are defined for ABDM. Those are considered looking at the continuity care scenario. These HR types are outpatient consultation notes. So whenever a patient goes for a OP visit, a consultation record gets created, that needs to be shareable. A prescription record, a discharge summary for IPD purposes, diagnostic report for pathology as well as for radiology, and immunization record for sharing of the immunization related information of the patient. And then there are 2 more special types of record types being added. One is wellness record, which is specifically defined to take care of the requirement of on the fly data sharing through the smart devices and the applications. So we'll discuss about all of these 7 HR types in detail in the next slide. And aim is to cover most of the healthcare record document sharing in a care setting. That is the aim of ABDM profiles. Okay. So there are total 7 clinical artifacts, 37 resource profiles, which are done for this use case. All the other resources can be referred from the existing standard specification without any changes in those specification. And then there are 19 terminology value sets created and 35 examples also there. So these are the different HI types and the content of those HI types. So in a brief, diagnostic report will have the header. All of these HI types have headers because they are derived from composition as a resource. So header has patient demographics, care provider detail, encounter detail, the attestation details, and so on. So all of them have these header as a basic information. Other than that, diagnostic report record has the diagnostic laboratory report. You can have either of one, either the laboratory report or the imaging report. And then the laboratory report covers specimen collection related information, results, conclusions. The diagnostic imaging report covers imaging details, results, interpretation of the image of the diagnostic report, whatever is provided. And there is one more section which is document reference. So why that has come, I'll talk about them later. So all of these HI types have been defined with a thorough thought and a brainstorming, multiple feedbacks and reviews from experts to cover maximum things that can be covered for sharing of the data. Say, for example, discharge summary has chief complaints, physical examination, allergy. So all of them are included in different sections, and all of them are optional. So you can have one or more added based on the use case. So you need not populate everything of it, because everything is not mandatory. Very few things are mandatory, and then based on whatever data collected within your hospitals or within your healthcare system, you can add those data on along with within this health record. And the similar way, you have the outpatient consultation record, you have a prescription record where you can have medications which include medication statement as well as medication advice. So you can use both of them there. So I'll talk about what is this document reference and binary in later slides. And this is the way the other records are also there. So other than wellness records, so where it takes care of all the on the fly measurements that are coming from smart devices or for continuous monitoring purposes. For example, it has a section which captures all the vital signs, including heart rate, respiratory rate, SpO2, and so on. And then there are multiple sections there. There's one special HI type, which is health document record. It is only for the purposes for scanning the older records from only from health locker. So other healthcare, other systems in ABDM should be able to read this health document record. However, the creation happens only through the health lockers. That's the constraint for health document record. This is specifically designed where patients may have their old health records which are not there in the different hospitals as well, and they want to put them as part of their whole electronic health record that is coming in over ABDM, linking it with their HI type through a health locker, and they don't know actually what type of health record it is. Very possible to categorize it, whether this is a diagnostic report, whether this is this kind of report. Then they can scan all of those records stating this is a health document record. So this is a special use case for which this HI type is created. And this is an implementation guide where all of these profiles which are done for ABDM purpose are hosted. The guide is IG is hosted, and we release this IG on the basis of the requirements and changes which are identified based on inputs from NHA, from community whenever required. And the IG also tells you how to use these resources. There are more explanations provided on why this structure is and how to use it, what is the purpose of particular structure. Now, how do you read these profiles? So, for example, I was telling you about the cardinality part. So, every profile has a text summary which provides a human readable summary of changes that have been made into that particular profile. The profiles also have a text summary, and it has a differential view where it mentions what elements have been changed while profiling from the existing international specification. It has mandatory elements given with the cardinality 1 or 1 or 1 or star, and there is something called S sign. This sign states that the element should be supported, must be supported. Must be supported meaning in ABDM must support means the receiver, the HIUs must have the capacity to read the element even if it is optional. So element might be optional, the cardinality might be optional, but if a HIP is providing this information in such an element, then the receiver must have capacity to read this element. So you cannot ignore information provided in an element which is marked as must support in ABDM. And that's what this sign shows. So while designing, if you are developing an HIU and you are receiving data and you want to read this data, you just can't ignore data which is there with the S marked on it. So you can check on this profile specification and then decide how do you render such a data, how do you provide the information on such data. And this is how the profiles look like. If you see here, this is a composition resource, and it says this is a composition resource for one of the HI type, and it says that the text summary says that it has 7 mandatory elements, and for all these 7 mandatory elements, there are 30 nested mandatory elements. And it has 38 must support element, and it has 33 fixed values. So if you have fixed values which you need not populate, they get automatically populated. So for example, when we defined different HI types, we took composition resource and we said, what is the type of this composition? It has a fixed value. So you can see here, this is a discharge summary HI type. And if you can see here, this is a fixed value of this HI type. It is a discharge summary. So while reading, if you read a composition and read and this and you kind of want to check what is the type of this record, you read the type where the value is coming as this as a discharge summary. It's always a discharge summary record. And that's how the fixed values have also been added for Case of Implementation for all the users. Now, this is how the structures of all the HI types are kept. You saw there was something called document reference in all the structures, right? So FHIR standard supports data sharing. However, the way we defined and we designed these HI types are very unique. NHA wanted to support all the 3 formats of data sharing, where if you have a older record, the scanned document, how do you support? So these are the different requirements of data sharing mechanisms. So for those, we said that the way the profiles are defined, you can share scanned document. The scanned document can be shared through document reference as one of the section in all of the HI type has one section called document reference. So you can share share scan document through that mechanism. But why is this there? It is there to support historic data, which allows quick onboarding of all the healthcare application developers. However, there are more granular ways you can support data sharing. The second way is the structured data without standard terminology. the way file structures are defined and the way our HI types are also defined, they allow structured data sharing also. So there is a flexibility to include free text. So for example, you can see here in the text, you can put abdominal pain in a condition resource in text element. You can see here the subject reference is given patient with an identifier. So you can give the identifier as one, the ABDM, the health ID, patient health ID as identifier in the reference, patient/health ID. This is possible even if, so for running systems, you should allow structured data entry also. So just not always support scan document. And slowly there is the desired way of data sharing, desired format of data sharing for NHA and for everyone who where we want to be able to use data in a more meaningful manner, which is the fully structured with coding and terminology format. So you can see the SNOMED city identifier has been added with a display text, which is the preferred term used for an identifier. It says that the system is SNOMED, the code is this, and the display is placement of stent. It's a procedure. This is the snippet from procedure resource where what procedure was performed is being mentioned in the code coding element. And even you can put a text here, which then further can be processed by any system who do not have coding system support as well. Now, why the third format is more appreciable? Because it helps you to provide better understanding of data for the receiving systems, make it more interoperable, processable, and help you to do a lot of analytics on top of these kind of data. So that's the desired format. Although we understand currently many of the implementers are working on onboarding to ABDM, understanding ABDM data APIs, but ultimately when it comes to data sharing, the desired format is the last third, fully structured terminology coded format. And how do we develop these HI types? So these HI types we develop following these 4-5 processes where we do requirement gathering. We do requirement gathering through the different entities involved. So NHA comes in, the community comes in, we receive some requirements, use case over our emails stating, these kind of data we want to share, but it's not possible. The current, there might be constraint on the current profile, there might be a requirement to create new HI type altogether. And we kind of then try, analyze, and see if these requirements, these use cases are really worth adding into FHIR profiles for ABDM. Then we start designing, developing the FHIR profiles where the multiple teams are involved to design these HI types also. In all the process, a go ahead and a review from NHA team is always there. And we finally, after review, validation through experts to community review, we finally host them. This is how the process of ABDM HI type development happens. So if implementers are facing any issues while validating or while creating HI types or while adding entity, and there are some data elements that you're not able to map, Nrcs can help you to do that mapping. Nrcs can help you to see if there is some gap identified, and we try to resolve those errors as well. So all of them is possible. Any new requirement can also be shared for adding to the ABDM HI types. So this is a continuous, always evolving and improving process, and we expect more and more participation from community. Okay. And about Nrcs, so National Resource Center for EHR Standards has been set up by Ministry of Health and Family Welfare, Government of India. And Nrcs has been tasked to support standardization to all the implementers in the country, whether they are public or private implementers, from all the parts of the country, so all everywhere NRC supports. And we have been also tasked by NHA to support standardization in ABDM ecosystem, and that's where NRCES is responsible for hosting and maintaining FHIR implementation for ABDM. We also create multiple value sets, coding sets as necessary in Indian scenario, using existing standard, Indian standard, and so on. These are the various activities of NRCS. So all the implementers, whoever are trying to integrate standard, including SNOMED, LOINC, FHIR profiles for ABDM, can approach NRCS for any of the supports required. We have some free and open source toolkits, a few FHIR sample codes for creating FHIR HI types are also created by us, other than these SNOMED, LOINC, and other coding system toolkits. We do provide free trainings on further understanding of any of the standard required, or any specific trainings as may be needed to the implementers. And there is a free of charge implementation support from NRCS also coming in. And there are some other activities that we do. These are the few statistics of NRCS. We work all around the country, and so far we have sensitized more than 11,000 professionals who are dealing in healthcare and healthcare standard space. And coming on to the hands-on on ABDM HR types creation and validation, I would request Siley to take over after that. But before that, I will now show you here, if you can see on the profiles part. Again, we are on the patient resource. Now you go to the to this IG. How do you read it? When you read it, here are the background, introduction, and how to read this guide. The information is provided here. What are the things that you should consider? And then these are the 7 HI types. Their description is also provided with the definition. If you can check one of the HI type, let's try and check diagnostic report record over here. And let's see here, you can see the text summary. It says the diagnostic record has 8 mandatory element, and there are 10 must support element and 4 fixed value element. And it has these multiple structures included. And you can see here the document reference being one of the resource added. This is for supporting the first use case of sharing scanned health records. But if you kind of then check the differential view, you can see here the flags are there, which are must support, a few things made mandatory, and so on. And then I would show you. So here, this is again a composition resource, as we discussed. And if you kind of check in composition resource, there is a section, and then every section has multiple entries. So if you are adding a pathology report, you can add in this section entry as a diagnostic report, either a diagnostic report laboratory, which is defined again for ABDM, or you can have a diagnostic report imaging, which is again defined for ABDM purpose. And either of them you can put. So this is all very, very structured data entry. And then ultimately you can see there is another entry, which is document reference. If you don't have any of them and you want to upload a scanned document, that goes here. And if you see the entry has a required that you can either have 1 or maximum 2 entries into it. So 1, either this can come, or 2, either this, a structured as well as a scanned copy together can also go. So there could be a use case where you want to provide structured information, as well as sometimes there is a scanned document which you want to attach on top of it. And this is how you need to read. So all of these HI types also have the similar structure. So if we just try to see one more, like discharge summary record, if you see again the top structure is same. The composition, it starts with a composition resource, and then it has multiple elements. And then if you can kind of see, the section can have either 1 or more, any number of elements here. You can include chief complaints, which is ultimately a condition resource. You can have the physical examination, which ultimately goes as an observation resource. Allergies as an allergy intolerance report resource. and medical history as a procedure. So all of them have been defined, and all of them are non-mandatory. So whatever are there in your system supported, you can add them here in those resource. And whatever are S marked, the must support marked element to be supported by all the HIUs who are receiving this data. So you can see here the medications are also there in one of the section, procedures are also there, and so on. And then again, ultimately, there is a document reference where you can attach a scan document, which is for the first use case, which was discussed. So all the HI types are in the similar structure. If you can read one, you can read all of them, all in all. Uh, that's it from my side. Over to you, Siley. You want to run through the presentation slides view first and then go on the demo?
No problem. I will take that.
Yeah, shall I share it for you?
No, I will share.
Okay. So I am stopping the share from my side.
Yeah, hello everyone. I'm Siley and I will be taking you through the uh, how exactly you will create those HI types and what are the ways that you can validate those HI types. So I will be mainly demonstrating how you can generate programmatically using Java language and a happy tool provided by the one of the free and open source tool with which we will be generating these HI types. Validating, I will be demonstrating two ways of validation. One using a happy library and another validation underscore CLI jar that is provided by the FHIR only. So to start with, how actually you will generate these profiles. So to help you in this, NRCS has provided usage samples which are programmatically generated using happy library, and it will generate all of the HI types available for you, each and every resource in it and mandatory field in that resource. So NRCS has developed these usage samples for the implementers, which will help them to quickly onboarding to the ABDM network. So because the first thing is to generate the structure in a FHIR format, which will be getting transferred into the ABDM system. So where you can get these samples. So since Manisha has already told you, NRCS provide different services. So one of the services that we provide is we provide tools and technologies which are the tools and technology developed by NRCS and which are free and open source tools and technology, where you can see this ABDM FHIR R4 usage samples. Once you click on this, you will get a zip file. Just give me a minute. You will get a zip file where you will have all the samples available. I have already downloaded. Uh, so when you download the sample file, this file will have a sample course which will using Happy Library. Along with these samples, you will get a README which will help set up or the which will tell you what all prerequisites are required in order to run through these sample codes. I hope my yes.
Sally, we are losing your voice in between. It's breaking. Could you go back again 2 to 3 minutes and then start from downloading of samples? I think your voice was not audible.
Okay, I'll do that again. So as I told you, the sample codes are available under the services section under tools and technologies. Tools and technologies that are provided by NRCS are free and open source tools. So when you go to that link, you will get ABDM FHIR R4 usage zip. After downloading that zip, you will get into that zip a readme file which will tell you about the what is there in the that zip, and the prerequisites that are required in order to run those codes. So all these test codes we are providing here. I will take you, I will import those in Eclipse. What I have done is I have created a Maven project where I have, added all the dependencies that are required for this for these codes to run. These are all happy dependencies. So I have, I'll tell you the brief about the how we are, providing this source code. So you can see a resource populator class where all the resources are populated with the all mandatory fields. All mandatory elements presented in a resource as per the ABDM profiles are populated here, are generated here. Now these resources are then referred by the other profiles, like the HI types. Considering the prescription sample, I'll tell you how we are generating this. So what we are demonstrating in this sample code is generating the prescription record programmatically using Happy, where we have populated all the resources present in a prescription record. Then we are programmatically validating that resource. uh, First, we have populated all the prescription bundle here, uh, in a populate prescription bundle method. Then we are validating that whether the generated programmatical object is valid or not. We are validating with the Happy library here. If the file is validated properly, what we are doing is we are writing it in a on a drive, right? So we are serializing it. Once it is serialized, what we are doing again, if you have a use case where you have already existing record, what you will try to do next is to parse that record, right? So if you have a the record available, what you will do, you will parse that record and then again validate. So this is how we have designed this demo code, where you will be able to generate record programmatically, serialize it over any given file folder. Then if you have already generated serialized record, what you can do is parse that record and validate it. It covers all the use cases where you generate validate the record. So I'll run this code for you. So okay, the main thing is what we are doing here is the validation is against the ABDM profile, right? So in this process we need to have those ABDM profiles. So under init method, if you see under init method, we are loading those ABDM profiles here. If you see, we are loading the profiles. We are initializing our source code to load first what all profiles we required, because the validation has to happen against those profiles, not the FHIR base profiles. So what we can do, we can have the profiles here under under download section of FHIR ABDM guide, and profiles and value set. You can download package as well, separate profiles and example as well. So I have already downloaded the definition. Profiles are nothing but the structure definitions, and you copy those structure definitions to some folder location. So here I have copied all the structure definition or the profiles of ABDM, right? So in order to validate against these profiles, I have given I have mentioned this path कि my profiles are available here. All of my profiles are available here that you load first, right? Once the profile are loaded, this whatever generated record that I have generated using setters and getters, right? When I'm populating practitioner, I have set identifier and other things. So all those profiles will be validated against these my ABDM profiles. So when I try to run this code, you see, since I have told you, let me in main, what I have done here is I have populated the prescription bundle. In populate prescription, if you go through, I have populated the prescription bundle by mentioning all its mandatory elements. Right, so that mandatory elements are then that record is then validated. If the record is validated, then I am what sys out, I'm doing out, so I'm printing the validated populated prescription bundle successfully. Now I want to write that bundle to some location. So I'm taking this location. So as you are aware that the profiles are available in both XML and JSON format, here I have, for the demonstration purpose, I have taken XML. So whatever profiles that I have loaded is of XML type, are of XML types. Now once I have serialized that XML, I have again validated it. So in that validation, I have serialized here. So this is the uh, programmatically generated prescription record you can get. The warning shows, because I have not included the value set in it, I have only included the structure definition. So warnings against that are showing. So the as far as the structure is concerned, the profiles are correct. So this is how we have provided all the programmatically population of all the HI types for ABDM and for its mandatory field. So now this validation has happened against the using the happy library. Now I will take you to the validation where validation of ABDM HI types using the validator underscore CLI .jar. This is the command line tool that is provided by the HL7 FHIR. So where you can get that validator is here. If you see, if you go to the download section in FHIR, you will get this implementation tools section where you will get the validator. Okay, under downloading the validator section, if you click on this, see, if you click this, you will get that jar. So I have already downloaded the jar for you. And once you get that jar, you copy it in some folder location. Then with the help of command line, you go to travel to that folder location. And what you can do, you can also download the samples that are given by NRCS. Hello, is my voice audible?
Yes, Sally.
Yeah.
Go ahead. Go
Sorry, I'm
ahead.
not since I'm sharing the screen, I'm not sure whether I'm okay. So with this validator you can validate the examples that we have uploaded on the IG. So where you can get that examples I have shown you under the download section of the IG. You can download the examples, right? So I have already downloaded the examples here. And if I want to validate example, keep that example parallel to the validator underscore CLI jar. So here I am trying to validate the diagnostic report imaging example for you, where the command goes like java hyphen jar validator tool, the example that I want to validate, then the hyphen version option will provide you the version of FHIR, which is that we are following R4, and the IG against which we are validating the our examples. So when you enter, it will first load the base core profiles, and it will show you what terminology server it is referring to. So as you can see, the profile, the example is perfect. It has zero errors and some warnings which can which you can ignore right now. So now if you see, since you can see the profile is validated, the record is validated as per the our ABDM profiles, we have patient identifier as a mandatory, right? If we see the diagnostic report and the subject where we are referring to a patient, and under patient identifier is mandatory, right? The value is mandatory, the value of identifier is mandatory. So let's see if we delete that identifier. So we need to find a subject patient, subject where patient is being referred. Now here is the patient, and here is its identifier element and the value element under identifier. So according to our ABDM profile, the value part is mandatory. So let's see by you know deleting this. I'm saving it. Now again try to validate. Now you can see it is showing me the 15 errors because patient is being referred at multiple places, and the error is because the value cannot be empty. So that is why we are sure the profiles or the record are being getting validated with respective of the ABDM profiles. Now it is just the value is not the thing, right? Element in a profile adhere to some structure, a type, a data type, right? So where if you see a birth date is of type date, right? So date is a data type which follows a specific format. The value of a date should be in that format only. So when you check a date, it should have this format. So if you see, right, if you see and you change the date, like the if you change the date in a format which is not supported by the data type here, like the one of the supported format is this, right? This. So what I have done is instead of 4 year I have deleted one digit, right? Now I am trying to validate this record again. since it's a huge bundle.
And this validation is happening from the existing hosted online IG. That is why it is taking time.
Yes, yes. So not a valid date. It is showing error as not a valid date. So just to confirm, just to let you know that the validation is not happening only on the required or the mandatory fields, but the data it is contained, the data that it is containing should be in a proper format also. So these are the different ways that you can validate your generated profiles, and this validator jar has different options that you can provide, which where I have demonstrated you the command where already hosted IG is there. Also you can do validation against downloaded profiles, where the profiles are kept in kept at some location, you are validating against that profile. Okay. Then again, if a particular version of Snowmade CT that you want to validate against, you can provide a hyphen SCT option, where a specific version of SCT will be targeted, and your profiles will be, or your examples records will be validated against those profiles. So this is the overall validation that you can do at your end using Happy Library and a validator jar. This validator jar is it's continuously now what we have observing is it's continuously getting enhanced in its feature. It is getting updated very frequently. So even if while validating the uploaded example, if you find some examples are not getting validated properly, so please let us know, because the jar is continuously updating with new checks on validation, and that way we will be very sure whether our examples are up to date or not, and you can have correct examples on IG also. So this is all we provide in terms of onboarding. While onboarding to the ABDM, what all you can do to create these FHIR profiles and how to validate it. And in any doubt, if you have any query doubt, please let us know at nrc-help @cdac.in. This is our support email ID, where we will address your all queries, doubt, and we will try to resolve it as soon as possible. Thank you.
Thank you very much, Manisha ma'am and Sayali. Now, anyone, if you have any question, please ask. Ranjita Shetty.
Um, Hello, Manisha. This is Shubham from TSS Mumbai. I am HL7. I am HL7 International Fire Certified. So I just have one question here. Just like we in Indian healthcare system, we have a lot of legacy systems, right, which are having very old infrastructure. So how we are going to manage this interoperability change? How we are going to bring those information systems into communication, because this is quite new. And when we are talking about legacy systems, so they were designed to pre-include interoperability aspects, right? So how do you feel like how we are going to bring those old systems into communication? Because that will, if we are bringing FHIR in practice, then it may also create some kind of negative response by the providers as well, if it is not working properly, right? So what are your thoughts on that?
Right, Shubham. That's the big challenge, and I think that's the challenge in every country and every place out there. Even US also has the similar challenges when they want to kind of move to FHIR. Right? They had a lot of V2, V1 kind of systems also, HL7 supporting. So that's the reason. That's why when the national this national ecosystem and a bridging gap while ABDM is started building, they did not kind of adopt FHIR as full standard, because you are already certified, you know there are all kind of unit operations are possible, and at a national scale you may not desire to have one single resource based data sharing happening. Most of the time it is after one encounter is completed or a health event is completed, right? And that's where for ABDM the document based data exchange approach was adopted, and FHIR as a structure has been adopted. So if you want to have data interoperable for these legacy system at any given place, you have to come up with at least one thing that is the standard format of data, and that's what has been adopted. While it is kept to all the implementers whoever are designing new systems, it is suggested that you can always use whole of the FHIR specification, even for data exchange, data storage as well. And but while you are sharing data over ABDM has its own APIs over which you just share the FHIR structure. That's the only requirement, which is minimal to for all the legacy systems also to be able to onboard. The second thing that was also kind of considered was the data sharing. As I explained in my presentation also, there are three ways you can share data. So for any of the historic data or any legacy systems which are so difficult to get converted or maybe redesigned, for those systems maybe a document a scanned mechanism is also there in place where they can share data through that format. The first requirement is to be able to share data in a format that the other system can understand. Then the level of structuredness into those records can be brought in slowly over the time. That is the aim.
Sure. And we are looking at IHG or DICOM, you're taking into consideration. And
Yes,
also,
yes, of course. So it's not just the FHIR standard. There are four. If you talk from the healthcare angle, I'm not talking from the consent management, data security, and privacy requirements, but from the data content point of view, there are four standards that are there. FHIR, DICOM. Of course, DICOM is there for medical imaging because that's the only one current standard which in entirely which can support the overall medical image data capture and representation. And in FHIR also, if you can have a look at this diagnostic report record, there is a provision to even attach a DICOM file, or also if the data is available, then a link for your own internal HMIS system, a link to the PACS can also be put into that resource out there. A DICOM file can also be attached in FHIR. So that provision is already there. And other than that, SNOMED, LOINC, and ICD-10 have been supported for now. Although ICD-10 has not been added at any places in current profile definitions, but over the period, if we receive the requirements from NHA on the insurance use cases and the claim processing, then ICD will play a major role in that section.
and you have this different profile, right? Sorry, actually I joined late, but I wanted to understand you guys have created different profile for that, right? We are not taking US core profile or Argonaut profile.
No, not at all. US core or any other existing countries' profiles we have not referred. We have FHIR profiles for ABDM, and implementation guide is also hosted out there. So you can, even if you search on Google FHIR profiles for ABDM, you will get the first link to the implementation guide out there.
Okay. Thank you so much, Manisha.
Thank you.
Thanks.
Are there any other questions? There are a few people who have raised the hand.
Kaushik Saha.
Yes, I have a question. Actually, we are facing some problem in the encryption and decryption part. Like while sending the message, uh, we are not able to receive the decrypted messages properly. So, is there any proper guidelines as to how, or some sample code proper regarding this?
This requirement, the question is about encryption and decryption. Maybe Binay or anybody from the team can handle it. It's not specifically on FHIR.
Yeah, sure, we will take it up. Sir, it is being requested to you. Please write us to AVDM support team in email, and we will get back to you as soon as possible.
Yeah, we have already written, so I can forward the mail again. So it will be very
But
helpful if
actually,
you
this
can.
form is for FHIR only. So I would like to request you, please write to us. We will get back to you as
Okay,
soon.
sure.
Yeah.
Okay,
Thank you.
definitely. Thank you.
Rupali Gupta.
Good afternoon, ma'am. We are a young startup in the wellness space, and we would like to integrate with ABDM. So I was wondering what kind of wellness records are you all looking at, and what kind of parameters to integrate?
Right, Rupali. So the way the wellness record is designed, we try to kind of capture the information which are on the day-to-day basis. Patients on themselves kind of try to put through the wearable devices, like we try to look at the different set of wearable devices that are there and the data captured in those wearable devices, and then try to put them in a format that can be shared and then processed at different application level. And if you have any other specific use case in terms of the wellness record, there's one more section that we have added, which is about women health also. We thought that's also very important in terms of keeping the wellness up to date and putting any information that is needed from the from the women health perspective. And there's one more section which is about the lifestyle, which is more or less many times required in terms of keeping or checking wellness of patients by the doctors. Sometimes it's very useful in mental health related problems. So that part is also kept. So, and if you think that there are any other items that can be added, then please do write to us, because many times what happens, these use cases are always evolving over time, and there might be certain elements that we may have missed. So if you have any use cases, you can definitely write back to us and we can have a look at it and see and propose to NHA that those also can be included. And the way the structures
Sure,
are,
ma'am.
they are all optional sections. So one more section which is relevant should not be a problem for any older implementations. So what we
I
ensure
see.
is whenever we do profiling, we ensure that the older work should not get affected. So whenever we add on top, not like do something which will hamper the whole base implementation.
Right. Since wellness records parameters are going to be optional in your data structures, I was wondering then how do they integrate with the other records? Because if everyone is keeping them optional, then no two parameters will match from two different providers.
So see, the problem is it's not that the record structure is optional. There is a standard structure. So for example, if you say I have a clinic and I want to document three set of information in terms of clinical condition. I say weight, height, and also every time I take the temperature. Okay. But there is one more place where weight, height, temperature, as well as blood pressure is also required. That's the practice. That's how the clinic works. And then whenever both the systems are receiving data, we also kind of uh, we also urge that the way you design your system should also be flexible enough to read data from from any receiving system, and that's where these structures are very important. So when I say the way condition resource is designed, you can have one or more conditions, right? So you should be dynamically able to read all the three conditions coming from one care provider, and then the four conditions also from coming from other care provider, and then there could be the fifth one. So and you know, nowadays our databases are also can be designed in such a elastic way that you can have these structured data placed in provided we have the coding systems as well there in place. You can dynamically render these details. So just giving some thoughts.
Yeah, no, wonderful, ma'am. Thank you. And if I may, just one more question. Where is this data being stored now? Because when we are giving it to ABDM,
On
is
ABDM
it
you
in
are
a
asking?
centralized?
On ABDM you are
Yeah, when
asking?
we link. Yes.
Okay, so the ABDM has built a backbone for data sharing. It acts as an HIE, Health Information Exchange,
Okay.
and it doesn't store any data. It doesn't have any connotation called centralized database or anything. It has registries. It has patient registry where patient health IDs are stored. It has provider registry. It has the facility registry, and it will have a number of registries in future which are necessary for identification and authentication of entities. Other than that, all the data resides at their own healthcare institute level, at different HIPs level. And whoever requests data, ABDM acts as a bridging gap. It provides standard API, standard structure for data sharing. Everyone shares data and works the way they are working on entire and in an entirety. However, I think HIPs have been the way the HIPs the certification for HIPs is given. They are supposed to keep the data always available for any systems who may require that data. And it has something called index through consent manager where it knows where the data is for routing the calls.
Great. Thank you, ma'am. Thank you.
Yeah.
Sai.
So one question.
Hi, Manish. I just had a question regarding coding systems, right? So there are a few which are well accepted, like SNOMED, LOINC, and whatnot. So in places where this coding system is mandatory, where we have to use it, is it possible to use a system which is internal to us, or it has to be a standardized system?
Can you explain this question again, Sai?
Like if we have our own coding mechanism, which we use internally, like we have our own entity resolution, like a condition like a fever is our own code.
Right.
Can we use that to share information, or does it have to be standardized with SNOMED or LOINC?
Right. So, Sai, what you're asking is the second way of data sharing. If you remember my slide, there was first way where you can share scan document. There was second way where you want to share. You can share in a structured way, but without the terminologies which are recommended by NHA. Right.
Okay.
That's the second approach that you are doing. However, it is always recommended you go for the third approach. If you have your own entities created, masters created, I really suggest that you go for standard terminology. And if any support needed for integration of SNOMED City and Nrcs can do that also. All the support is free of cost.
Okay.
So
And,
it helps your own structure also to be standardized. So I believe after doing consultation for so many implementers, whatever masters you have, SNOMED has more terminology and clinical terms than what you have. So you will be benefited.
So in extension to that, just maybe follow up to the SNOMED part. Like how do we get access to the full set of SNOMED codes? Like, is there an API or is there any resource guide for that?
Okay, so all of that is available. So SNOMED CT codes are distributed in tab separated files. And NRCS has developed free and open source API SDK, which you can use to integrate SNOMED City. SNOMED City file access is also free for everyone for usage within India. You just have to register yourself as an affiliate within India.
Okay, thanks. Yeah,
All the information is available on NRCS website. So if you just do nrcs.in and go through the relevant section, and if you don't find anything, just drop an email at nrc-help@cdac.in.
sure, that helps. Thanks, Ved.
Few queries reply has given on the chat, so you may also refer the chat. Yeah, Shyam.
Hi, Manisha. I'm
Hi,
Shyam. Currently, we are in middle of milestone 1 implement, but soon we'll be starting milestone 2 and milestone 3 implement. I have two questions actually. First is that you have shown happy FHIR implementation, right? That is for Java, if I'm right? So if you want to do it in .NET, and is there any libraries available to do
There are libraries available on the slide. If you just check FHIR reference implementations, you will find the page where all the different open implementations that are there will be listed, and there is one in .NET as well. So that the demonstration was just for one single demo of how you validate, how do you create resource objects using Java. You can do it in your own languages, whatever technologies you are using. That's not a problem. And there are ample of reference implementations available. And if you don't find any of them, please do let us know. We can help you on that.
Okay, how to reach out to you? Like,
nrc-help@cdac.in.
NRC hyphen.
Let's put it on. Sally, can you please put it on the chat? Yeah.
Okay. So my second doubt is that in milestone 2 and 3, it is mentioned that to initially begin with, we can attach document. So you also mentioned that we can attach document inside the FHIR, right? But I am not really clear, but exactly how to do it while in practice, if we are going to do that.
So you need to create composition resource object first. Then in that resource object, the composition, not composition, you have to create the resource object of one of the HI type, whichever you are planning to use. Say for example, prescription, if you're using, prescription supports binary more than a document reference. You can add any binary format. And say for example, you take discharge summary, you create the resource object of discharge summary, populate all the mandatory information of the meta, of the bundle, of the composition record, like patient, encounter details and other details, and then and then create a document reference object and populate it as part of the one of the sections. And that's how your object get created. I'm just talking from the Java world, from programming side, and I hope you understand that. I don't know from which world you are coming in.
Thank you.
Yeah, please.
Yeah, hi Manisha. Just adding on to Sham's question. So basically, how will heavy documents be shared, and like what will be the downtime, or what's the fallback if the record fails?
Okay, these are the really good questions, but they depend on Binay. If you can answer this query on what is the maximum data packet size is supported over ABDM. I think there is no limit as such. It depends on the network and the bandwidth that you are using. But if there are guidelines, Binay,
exactly. There is no limit at present, but we will get back to you, sir. Please send an email to us, integration.support@nha.gov.in. You can see our email ID on chat also.
on profiles we have not kept any data limit or something like that, even not mentioned anything on the implementation guide. But Binay, if there are any such limitations, then please do let us also know. We can add specifically on the guide. Yes.
Yeah, so basically like X-rays would be under this diagnostic report and yeah.
Yeah, got it, Apurva. MRIs are huge and big size. Sometimes go in half a terabyte. Then how do you take care of that? That's a good question. Yes.
Any more questions, please?
I think no. There are few on the chat, Binay. If you can read out, if we don't want to miss any of the questions.
Ma'am, on chat already we have replied to them, and we
Okay.
will coordinate with them, ma'am.
Okay.
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 Okay,
Sure.
once again, I would like to thank Manisha ma'am and Saili for such informative session. And if still anyone have any query, you can reach out to us, ABDM Integration Support Team. Okay, thank you.
Thank you.
Thank you, everyone.